Good morning, everybody. Today, I would like to take another experiment for BSc 6th semester students, and today's experiment is determination of pH of buffer solutions using potentiometer. For this experiment, the actual procedure is like this. First, we will take bottles, reagent bottles, number 7, it is number 1, 2, 3, 4, 5, 6, 7, like this. Then, to all the bottles, we have to add 19 cc of 0.2 normal acetic acid into the first bottle and 18 cc of acetic acid into the second bottle, and we have to add 16 cc of acetic acid into the third bottle and 14 cc into the another bottle, 10 ml, 8 ml, 6 ml, like this. And finally, into the last bottle, we take 12 cc of acetic acid. So, acetic acid is added in this order in all the bottles with the help of a burette. Yes, sir. After the addition of acetic acid, prepare 0.2 normal sodium acetate and add sodium acetate in this order. To the first bottle, add 1 cc of acetic acid. Into the second bottle, add 2 cc of acetic acid. Not acetic acid. To the first bottle, add 1 ml of sodium acetate. And into the second bottle, add 2 ml of sodium acetate. Into the third bottle, add 4 ml, 6 ml, 10 ml, 12 ml, 14 ml, and into the unknown bottle, add 8 cc of sodium acetate. So these are the volumes of acetic acid as well as sodium acetate added in the different orders with the help of a burette. Look here, by adding acetic acid as well as sodium acetate, we are getting a standard buffers. So bottle number 1 to 7, these are called as standard buffers. Look here, by adding 19 cc of acetic acid and 1 ml of sodium acetate, 1 ml of sodium acetate into the first bottle, we are getting a buffer solution, 19 ml acetic acid, 1 ml sodium acetate. This is buffer solution, and whose pH is already known to you, that is 3.42. Okay, and second bottle is containing 18 ml of acetic acid and 2 ml of sodium acetate, and whose pH is equal to 3.72. Similarly, the third bottle is containing 16 cc of acetic acid and 4 ml of sodium acetate, whose pH is equal to 4.05. Like this, we are getting standard buffers from bottle number 1 to 7 by adding 19 ml, 1 ml, 18, 2, 16, 4, 14, 6, 10, 10, 8, 12, 6, 14, as well as 12 and 8. Look here, from 1 to 7, these are called as standard buffers because their pH value is already known to you. Whereas, the last bottle is containing 12 ml of acetic acid and 8 ml of sodium acetate, whose pH is unknown. And here, our aim is we have to find out the pH of this buffer solution using the potentiometer. And look here, for this one, connect the electrodes. One is the platinum electrode, another is gallium electrode that is connected to the instrument like this. After connecting the electrodes to the instrument, then switch on the instrument. And on the instrument, first we have to adjust the temperature. This is the temperature button. Usually temperature is in between 30 to 40, like this. It may be approximately 30 to 34, like this. Once you fix the temperature, don't alter that one until the experiment is over. Then we have to check whether the instrument is working properly or not. For this one, move this knob to the check position, and look at the screen. The reading on the screen is found to be 0, 0, 0. If it is not 0, then move this knob slowly until you get 0, 0, 0 on the screen, like this. Okay. So for the water we are getting 0, 0. Once it is adjusted to 0, then it is not necessary to move the standardize now. Firstly, we are adjusting temperature and we would check the instrument whether it is properly working or not by adjusting the knob to check position and standardize the instrument until we get 0, 0 on the screen. Yes sir, after getting this one, then take the solution of the first bottle. Solution of the first bottle. Solution of first bottle. First bottle, LED bottle, then the solution is taken into bottle, and again electrodes are put into the beaker, and just by placing electrodes into the beaker containing the solution, first solution, we are getting some reading on the screen. We are getting some reading on the screen. Record the number here. Similarly, the electrodes are put back into water, and now the solution is put back into the first bottle. Then take the solution of the second bottle, into the beaker. Then again electrodes are put into the beaker, again getting some of the reading. Like this, record the values that is found from the instrument in the observation column. It is observed EMF in millivolts. Similarly, take the reading of the unknown solution. Take electromotive force value for the unknown solution lastly. After getting the reading for the first solution, second solution, third solution, fourth, fifth, sixth, seventh, and also for the unknown solution. Finally, plot a graph of electromotive force versus pH. We are getting a straight line of this type. Straight line is obtained. Okay, and already from the instrument we know the reading for the unknown solution, that is observed electromotive force value for unknown solution already found by the instrument, and mark that reading on the graph here and draw a parallel line. It cuts the straight line at some point. From this point, draw a perpendicular line that gives the pH value of unknown buffer solution. Yes sir. After knowing the result, here you may ask a good question. Already you have completed the experiments, but sometimes you are asking a question like this: what is a buffer solution? And what is its composition? Look here, buffer solution is one that is composed of either a mixture of weak acid and its conjugate base. It is called as acidic buffer, or it may be a composition of weak base and its conjugate acid. For example, mixture of acetic acid and sodium acetate. This mixture is called as a buffer and it is called as acid buffer. Or it may be composed of a mixture of weak base like ammonium hydroxide and its conjugate acid like ammonium chloride. This mixture is also a buffer, and this buffer is called as alkaline buffer. So like this, it is a composition of a buffer solution, acid buffer as well as basic buffer. That's what completes the another experiment under physical chemistry for the 6th semester. Okay, thank you. Off